Hi students. So today I am doing a different thing rather than dealing with some concept of critical reasoning or a passage in English. I am discussing time, speed and distance. So yesterday a question was asked, a tricky question on TSD, and I said I will give the solution to this question, the easy way to deal with such type of questions. So let us see, this was the question. Right, so you can read the question and then I will explain the concept and how to approach the question. All right, so it says that Mr. Goyal travels from Delhi to Agra by a passenger train. There was some railway track repair work going on at a distance of 80 km from Delhi, so the train had to slow down to 80% of its original speed. It continued the rest of its journey at this slow pace and reached Agra 1.4 hours late. So what it says is that normally Delhi to Agra, Mr. Goyal travels from Delhi to Agra, but on a certain day, there was some repair work going on at a distance of 80 km from Delhi, because of which the speed of the train got reduced. Now, if the speed of the train got reduced, then definitely time taken would have increased, right? So it says that because the speed got reduced, Mr. Goyal took 1.4 hours more than normal. Then the next day, Mr. Gupta traveled by the same train from Delhi to Agra. This time, the repair work was at a distance of 120 km from Delhi. So last time it was 80 km, now it is 120 km. Again, the train slowed down and traveled at 80% of the speed for the rest of the journey, thereby reaching Agra 1 hour late. So in the same process, right? So before we solve this question, let me tell you some very simple thing. So if the in time, speed, distance questions, you will find in most of the question, either of the one thing will be constant. Either the distance will be constant, or speed will be constant, or time will be constant, right? So most of the time it is distance which is the constant. If we can identify which part is constant, we can solve the question around it. So in this particular question, every time you see distance is constant. So from Delhi to Agra, Mr. Goyal is traveling, so distance is constant. Now when distance is constant, speed, I'm taking speed as v, is inversely proportional to time. So automatically when we say that if my speed reduces by 80%, if my speed reduces to 80%, not by to 80%, if my speed becomes 80% of original, then that means it becomes 4 by 5 times of original, right? So if speed becomes 4 by 5 times of original, what will happen to time? Time taken will become 5 by 4 times, right? So if initial speed was v, it is now 80%. So new speed is 4 by 5t. If initial time is t, new time will be 5 by 4t. Let me take another example. Suppose I travel normally at a speed of say 100 km per hour. Sorry. I travel by 100 km per hour. But due to some reason, today my speed is 75% of my normal speed. So 75% means 3 by 4 times, right? So my speed is 3 by 4 times out of 100. I can take this as v also, but just to illustrate it numerically, I've taken 100. So my new speed is 3 by 4 times of 100. What will be the time? If normally I take say t time, say 1 hour time to reach a particular distance, today time taken will be 4 by 3 times, because my speed has reduced by 3 by 4. So time taken will be 4 by 3 into 1. You can calculate it separately also. This number doesn't have any significance, right? Let me give you another example. Suppose my speed reduces to 60%, reduces to 60%. 60% means now it has become 3 by 5 times of my original. So by how much will my time increase? 5 by 3t. Very simple concept. Speed is inversely related to time. You can obviously understand it by simple logic that if you drive fast, that is if your speed increases, of course you reach to a particular place soon. So time taken is less to reach the same distance. So this is the relationship between speed and time which we will be using in this question. Now this is the question. right? So whenever you read the question parallelly, start drawing the diagram. So it says that Mr. Goyal travels from Delhi to Agra. Let me take this as Agra. What happens normally? We will see. And on that particular day, what has happened? So let us say this is the first point. Let us read. There was some railway track repair work going on at a distance of 80 kilometers. Let me say this distance is point A, right? 80 kilometers, right? From Delhi. So the train had to slow down to 80% of its original speed. All right, fine. So it continued the rest of its journey at the slow pace and reached Agra 1.4 hours late. The next day, Mr. Gupta traveled by the same train from Delhi to Agra. This time, the repair work was at distance of 120 kilometers from Delhi. So let me take this point as B. Distance of 120 kilometers. The second day, wala distance is point B. So this will be 40. This will be 80. Okay. Again, the train slowed down and traveled at 80% of its speed for the rest of the journey, thereby reaching Agra 1 hour late. Now, what we have to do is we have to draw different diagrams. If you want to solve it quickly, it is always better to draw the diagram. What it is telling is on a normal day, this is what happens. This is the normal day, Delhi and Agra. Let me, yeah. So this is point A I am taking, this is point B I am taking. On a normal day, this 80-kilometer distance, this 40-kilometer distance, and this distance, whatever this distance is, I don't know. All the distance are being traveled with same speed V, with the same speed V. Let me say total time taken is T on a normal day, right? On the first day, when the accident takes place or the repair work takes place after point A, what happens is this is 80, this is 40. Let me again draw the diagram, similar diagram. This is Agra, this is Delhi. This distance I don't know. Okay. Okay, this is B. Now from D to A, train has traveled normally. From A to B, speed has reduced to 4/5. It becomes 4/5 V. From B to A again, it is B to Agra, that is, it is again 4/5 V, right? Okay. So this is what has happened in second day. Now what is given is second day, the time taken is T plus 1.4 hours, 1.4 hours late. So 1.4 hours is, if you convert it into the fractions, it is 7/5 times. I hope you know how to convert it into the fraction. 0.1 hour means 6 minutes. So 0.4 hours means 24 minutes. So 1 hour 24 minutes, convert it into the fractions. Why I have converted it into fractions? Because I am writing everything into the fraction. Now, if you compare these two things, if you compare diagram number 1 and diagram number 2, understand why this delay is happening. This delay is happening because train has reduced its speed from V to 4/5 V for a particular distance from point A to Agra. For point A to Agra, train's speed has reduced from V to 4/5 V, because of which train is getting delayed. Now, if the distance from point A to Agra has become 4/5 V, how much will time change? 5/4. Say I take A to Agra distance as TA. Normally it takes TA. So it changes by 5/4 TA. It becomes 5/4 TA. It is given that this new distance minus the original 5/4 TA is equals to 7/5. Understand this. This is the most important thing. Understand this. What we have found out, we are saying that the time taken has changed only after point A and from point A to Agra, because the speed has changed only at that point. Because of this time change, because the change in speed, time has changed, time taken has changed, and we are reaching 7/5 hours late. So this is one equation that I have got. If I have solved this equation, it becomes very easy. That time taken from A to Agra is, if I solve it, it becomes 5/4 minus 1 is equals to 1/4. It becomes 28/5. So I am writing it down here that A to Agra, I have found out A to Agra time taken is 28/5. I have explained you But if you realize, I have taken only one step as a solution till this point. This is my step number one. I have simply drawn the diagram. I have seen from which point impact is taking place and by how much has that changed my time taken. So this is one equation. This is my equation number one. Now let me draw the diagram for the second day of accident. Now what happens on the second day of the accident? This is D, this is point A, this is point B, and this is Agra. So now the accident take place, or not the accident, sorry, repair work takes place at point B. So till this point, train has traveled with speed V. Till this point, train has traveled with speed V. After this point, it travels with 4/5. Now compare this diagram with the second diagram. Compare second and third diagram. It will be easy. Why we are comparing second and third diagram? Just to see what are the changes because of which we are now saving 24 minutes. Now the train is reaching, if this normal time was TA, now we are reaching 1 hour late. 1 hour late, or from the previous day we are saying saving 24 minutes, whatever you want to say. So okay, right? So what is the point of impact here? If you see the point of impact or the change from, if you compare the diagram number 2 or diagram number and diagram number 3, the first phase is same, no changes. The second phase is changed. Second phase, last day I traveled by 4/5 V speed, and today I am traveling with the speed V. So today my speed has become 5/4 times in this second phase. The second phase of journey, 5/4 times. The third phase, everything remains same, so no impact there. If I compare second day and third day now, my time has only changed by 5/4 t. This was my second day time. This was my second day time between A and B. Between A and B. So between A and B, my increase, this A and B, between A and B, my speed has increased by 5/4, right? Because of which, sorry, my speed has increased by 5/4. So time taken will be 4/5 times, because of which I am saving 24 minutes. So 24 minutes, I can write it as 2/5. Right? So this gives me T/5 is equals to 2/5. Right? T/5 is equals to 2/5. That means T is equals to 2 hours. So this journey, the second day time is 2 hours. So I take 2 hours on second day to travel distance of 40 kilometers. So on second day, my reduced speed is 20 kilometers. This is my second day speed. If my second day speed is 20 kilometers, my original speed is 5/4 times of this, right? Because the second day speed is 4/5 times of original. So my original speed comes down as 25 kilometers. My original speed comes down as 25 kilometers, right? So I have now got my original speed as 25 kilometers. My original time from A to Agra is 28/5. My original time from A to Agra is 28/5. Then what will be the difference from A to Agra? It is time into speed. Originally the distance is 140 kilometer from A to Agra. But if I have to calculate this distance from Delhi to Agra, it will be 140 plus 80. That is 220 kilometers. So that is how you solve the question. I know in my screen now it is very haphazard, but if you have followed my step-by-step solution, I have taken 3 steps. Let me tell you again, summarize what were the 3 steps. First, I draw the diagram of a normal day. Then I draw the diagram of the second day. What has happened? Second day, I have seen that point A to point B speed has reduced. Point B to Agra again speed has reduced. Because of these 2 reduction in speed, my total time has increased by 7/5. Okay, 7/5 hours. 7/5 hours. My speed has reduced by 4/5. So time taken from A to Agra, which I have taken as TA, becomes 5/4. So I have subtracted the normal TA time of Agra from this time, which is the increased time 5/4. I have equated it as 7/5 because this is the total delay I am facing. I got how much time I normally take to travel from point A to Agra. This I have got. Then the next thing step I did was I draw the diagram for third day, or here you can say the second day, when the repair work shifted to point B. I compared it with the diagram of second day. So third diagram and second diagram, I compared it. I compared this two, and I see that only A to B is the point where speed varies between the 2 days. A to B is the point where speed varies. On third day, A to B speed becomes normal V. On the second day, it was 4/5. So again, from 4/5, if speed has become V, then my time taken will also change accordingly. Right? If my speed has become 5/4 times, my time taken will become 4/5 times. This is what I have done. Now, if on a second day I take T time to travel from A to B, this day I have taken 4/5t. I mean, the second day I have taken 4/5t time. I have equated it to, I have saved 24 minutes this day, so I have equated it to 2/5. I got t is equals to 2 hours. This t is equals to 2 hours is for second day. So distance of 40 kilometer, I have traveled in 2 hours. So speed of second day I got is 20 kilometer. If speed of second day is 20 kilometer, what is my normal speed? Speed of second day is 4/5 times of my normal speed. And this is 20 kilometers. So I can find my normal speed as 5/4 into 20, which is 25 kilometers. I got my normal speed. I have got how much time I take to travel from A to Agra. I have got everything that I need. Right? So if you observe, I have not taken any complex, I have not made any complex equation like X or something of that sort. Not taken total distance as D and D minus X, nothing of that sort. Only focusing on what has changed from day 1 to day 2 and day 2 to day 3, and because of that change, what is the impact on total time taken, because my distance is constant. I have not taken it at all. So I hope you have learned this concept and you will able to apply this concept in TSD question. Thank you very much.